Hello, viewers. So this is the third part, or let's say the last video series on 4.5. So here we're talking about exponential and logarithmic equations. So we have some problems to solve, some exercises. So here what we can do, we find the solution set of this equation. We can first of all rewrite absolute value. So don't forget that for absolute value of x, it can be written as what? It can be written as 4 to the power x, but this is when x is greater than 0 or equals to 0. Then 4 to the power minus x if x is less than 0. Now, since we have this equation, so it means this problem will become 2 as well. It will become 4 to the power x equals to 1 over 8. But this is when x is greater or equals to 0, or just greater than 0 will do. And we can add equals to 0. 4 minus x equals to 1 over 8 when x is less than 0. So you have two equations. So let's try to solve the two. So if you take the first one here, which is 4 to the power x equals to 1 over 8. So we can realize that this we can write as what? This is 2 to the power 2x, right? Equals to, this we can write it 1 over 8, we can write it as 2 to the power minus 3, right? And what does it mean? This means that we can drop the base. So you go with 2x equals to what? Minus 3. And this means that x is equals to what? Minus 3 over 2, right? But remember, this first equation we are solving here, it requires x to be what? To be positive or non-negative. But look at the x we got. The x we got here is what? Minus 3 over 2. So this has to be rejected. So we're going to reject this. Right. So then let's take the second one. The second equation comes from where? It comes from this one. This one is what? 4, remember, 4 to the power minus x equals to 1 over 8. But here we want x to be less than 0, right? So here we are rejecting, since, why are we rejecting here? Let's be specific. We are rejecting since what? Our x has to be greater than 0, right? Okay, because for this one, we're taking the first equation, x has to be greater than 0. Then this one also, we can write this as 2 to the power what? This we can write as 2 to the power minus 2x, right? Yes. And this is going to be the same, 2 to the power minus 2 to the power 3. We can write 1 over 8. So we can drop the bases. So you have minus 2x is equals to what? Minus 3. So you can see that x is going to be 3 over 2, right? But this also, we have to reject it. And why are we rejecting? Since the x has to be less than what? Remember, the x has to be less than 0. So this x, that is why we are rejecting. And here we can see, here we have the x to be what? Greater than 0. So that is why we are rejecting. So it means we have two solutions, but none of the solutions will work because both have to be rejected. And that is from the definition of an absolute value. So we are bound with no solution. Then for question number what? Question number 2. This we have to just solve. This we can write this as 3 to the power 2x minus 2 times 3. We can write this as 3 to the power x times what? times 3 minus 27 yes, equals to 0. So we can make substitution. Here we can rewrite this as 3x all squared minus 2 times what? Instead of 2, we can write it as 6 now. 2 times 3 will be 6. So you have 6 multiplied by 3x minus 27 equals to 0. And then we can let u to be what? 3 to the power x. So that we will have to u squared minus 6u minus 27 equals to 0. So, and this is nothing but u is going to be minus 9, right? And u plus what? 3 equals to 0. And this means that u is equals to 9 or u is equals to minus 3. So, but what is u? U is 3 to the power x. So we have 3 to the power x is equals to 9 or 3 to the power x is equals to minus 3. So clearly here we have 3x is equals to 3 squared. So x is going to be 2. But here, what can we do? This is 3 and this is minus, right? So you can just take log of both sides. So x is going to be log 3 of minus 3. But this is what? This is impossible. Right? So this is the only solution. So the solution has only one positive real solution. All right, so for this question, we're just going to multiply, cross multiply. If you cross multiply, you have 10x minus 10 minus x equals to 40, right? So what can we do? From here, we can say, okay, we can let our t be this. So we can say, okay, from here, we can say, let maybe u be 10 minus x. You can do it from here so that what is u? Here will become what? U minus 1 over u is equals to 40. Or before you do this, you can just multiply both sides by, you can multiply just both sides by 10 to the power x. And the moment we do that, what are we going to get? We will have 10 to the power 2x minus 1 is equals to 40 times 10 to the power x. So this we can rewrite as minus 40 times 10 to the power x minus 1 is equals to 0. And if you let u to be 10 to the power x, you will have u squared minus 40 minus 1 equals to 0. So here we cannot factorize this one, but we can use our quadratic formula, which is going to be minus b. In other words, just take a to be 1, b to be minus 40, and c to be minus 1. So doing that, you will have u is equals to 40 plus minus 40 squared minus 4 times a, which is 1 times c, which is minus 1, everything over 2 times 1. So u is going to be 40 plus minus, this is going to be 1600 plus 4, right? Everything divided by 2. And what will this be? This will just be 40 plus, this is going to be 1604 over 2. OU is equals to what's 140 minus square root of 16604 over 2, right? Now, if you look at this, These numbers, we just need to know which one is positive, which one is negative. This number is going to be, this is going to be positive, actually. This one is positive. But this one is going to be what? This is negative. Why? Because this is the square root. Remember, this is square root of 1604. Right? 1604. Remember, the square root of 1600 is 40. But you have 40 minus this one. So the numerator is going to be negative, divide by 2, so everything will be negative. Right. Now, why do we care about the negative? Remember, u itself is what? 10 to the power x. So, or you can say, we know that 10 to the power x is equals to u. So if we use u to be positive, so we need u to be positive because we are going to take log. So for example, if you take this u, which is positive, we'll have 40 plus root of what? 1604 divided by what? Divided by 2. And now you can take log. So x is going to be log to the base 10 of what? 40 plus 1604 divided by 2. So this will be a real number, right? But if we take this one is a negative number, this one here, and you said, okay, 10x is equals to, which u are we using here? We're using this second u here, this one. So let's say 10x is equals to 40 minus 1604. You see, this will be a problem. So x will be what? Log of what? 40 minus 1604 over 2. This is impossible. Why is it impossible? This is simply because this number here, 40 minus 1604 over 2 is less than 0. You can check that. You can take a calculator and find the root of this 1604, then subtract it from 40 is going to be a negative number. All right. So it means the only solution we're going to have is only one solution. That will make sense. Only one solution. All right. So let's put this demarcation here. Now for question number 4, what do we need there? So for question number 4, we have log to base x of what? Log 2 base 8 is equals to what? Is equals to 2. So what are we going to do? We're just going to change to exponential form. This is the base here, x. And now you consider this as what? Remember, if you have log to base a of y is equals to x. So you just consider this one first. So we just consider this one, this logarithm first, and this one. So if you do that, we will get that what? We'll take 2 to the other side. So it means we will have log to base 2 of 8 is equals to what? X squared, right? Then now we do it again. So this means that 8 is going to be what? 2 to power x squared. And now 2, we can write 2 as 2 to power 3 is equals to 2x squared. So you can see we can drop the base. It means that 3 is equals to what? X squared. If 3 is x squared, it means x is equals to plus minus root of what? Root of 3. But if you look at the position of x is standing as the base. The base here cannot be negative. So we take x to be root 3 only. And this is since x has to be positive because of the position of x. Because this x here has to be positive. So we go with A. Now this one, we said A is the solution. So if A is the solution, you need to find 2A plus 1. So here we just need to rewrite things clearly. This we can write as log of what? This is actually 4 minus x. And we can put the 2 here. This 2 can go up. Plus, this is also log of 1 over x plus 8. It's equals to log of what? 2x plus what? 13. Now, looking at this, we can change what? Something is missing here. Look here. This here used to be 2, right? There's a 2 here. And this 4, I can write it as half because of this root here. Then now you can take 2. If you take 2 up, the power will go. So you just have 4 minus x plus 1 over x plus 8 is equals to log 2x plus what? Plus 13. Now you can see that this 2 has disappeared here. This 2 is no longer here again because this 2 and this half will go, right? And now, so what else? You can multiply these two. So you have log of what? 4 minus x multiplied by 1 over what? X plus 8. And this is log of what? 2x plus 13. And this will give us log of 4 minus x over x plus 8 equals to log of 2x plus what? Plus 13. Now we can drop the what? We can drop the logarithm so that you have 4 minus x over what? X plus 8 equals to what? 2x plus 13. And now we can cross multiply. So you have 4 minus x is equals to 2x plus 13 over what? X plus 8. So we have 4 minus x is, this will give us 2x squared plus 16x plus 13x plus, I think, 104. Now we put everything to be equals to 0. This is 0. This will be 2x squared plus, here is 16 plus 13, 29. We move x to this side. This will become plus what? 30x. And this will be plus 100. Because we transfer 4 to the other side, 104 minus 4. So 0 is equals to, so let me just do this here. And the whole of this, this, and this one will give us this one, right? And this one here, 104, and x and 4, and this one will be the same. Give us 100. Okay. So let's push back here. So now we can divide both sides by 2. So this becomes x squared plus 15x plus what? Plus a 10. And this is x plus 5 and x plus what? Sorry, this is, you divide both sides by 2. This is 50. Right? Yeah, and this is 10. So we can see that x is equals to minus 5 or x is equals to what? Minus 10. But you have to look at it and see which one can we reject. Definitely we are going to reject minus what? Reject. Why? Because if we plug minus 10 here, let's put minus 10 here. If you put minus 10 here, you have minus 10 plus 2, which is minus 2. So you have 1 over minus 2. And we cannot take the log of a negative number, right? So I think minus 5 will work everywhere. It's going to be positive. If you substitute minus 5 here, 4 minus minus will give you 9. Here will be what? Here will give you 1 over 3, and here will also be positive. So this is the correct one. X equals to minus 5 is the only solution. So what that means is, if you look at here, it said A is the solution, right? So what it means is that our A is equals to minus 5. So you have 2 times minus 5 plus 1. And this is nothing but what? What do we have? We're having minus 10 plus 1. So this is actually minus 9. So the answer is not A, but E. All right, let's go to number 6. Number 6 here, you will see that what? This is also a logarithmic equation, but the bases are not the same. So the first thing we should do is make the bases to be the same. This is log to base 10. So this is base 10, 2x minus 1 is equals to, this is already base 10, even though it's not written. But you can see that this one is what? 1 over 10. So 1 over 10, we will use this property. If you have, I think we already saw this property, 1 over ax, right? It's nothing but minus log a of x. So it means we can change this to 10, but here has to become minus. So we have minus log of what? 10. Then we still have x minus 1. Now this, we can change this to division so that you have 4x minus 5 over x minus 1. So we're just changing this minus to division. Now this is log to base 10 of 2x minus 1. Now we can drop the bases, so you have 2x minus 1 equals to 4x minus 5 over what? X minus 1. Right, then now we can cross multiply as 2x minus 1, and what? X minus 1 is equals to 4x minus 5. Now if you cross multiply, 2x times this is what? 2. So this will be 2x squared minus what? 2x. Then also minus x, I think plus what? Plus 1 equals to 4x minus 5, correct? So here will be just 2x squared minus 3x. Then I'll bring this one here. So this becomes minus 4x. And this is going to be plus 6, right? Equals to 0. So we have 2x squared minus 7x plus 6, it equals to 0. So here we have to factorize. How do we factorize this now? So to factorize this, we can look for 2 factors. That's we have, when you multiply, you have 12, and when you add, you give you what? Give you minus what's, we need minus 7. So this is going to be minus 3 and what? Minus 3 minus 4, because minus 3 minus 4, when we multiply, it will give us what? It will give us minus 12, and when we add it to give us minus 7, then you divide this by 2, divided by 2. So here, this is just going to be 2x minus 3, and this is going to be x minus 2, right? Equals to 0. So from here, we see that I can remove this one actually. So this means that x minus 3 equals to 0, or x minus 2 equals to 0. So from here, x is 3 over 2, OX is equals to what? 2. Now we have to check which one do we reject. So if you take X to be 3 over 2, you put 3 over 2 here, it's still going to be positive. We put 3 over 2 here. 3 over 2 here, you'll have 4 times 3 over 2, which is 2. So this is still positive. Okay. And yeah, so it seems both of them are solutions. Yes. So both of them are good. 2 will also do the job. So this, we have 2 solutions. Very good. Now, so our solution set, we have 2 solutions. Both of them are solution. So what will be the sum? The sum will be 3 over 2 plus 2, which is the same thing as 3 over 2 plus what? 4 divided by 2. And this is 7 over 2. All right. So number 7 is saying that if x1 and x2 are what? They are solution, then we should find what is x1 plus x2. So the same way here, we can just multiply by what? By 10. This we can multiply by, so you just multiply everything, both sides, by 10 to power what? X. So that you have 10 to power 2x plus what? 6 is equals to 5 times 10 to power x, right? And now you can rewrite it as minus 5 times 10 to power x plus 6 equals to 0. And we can take u to be 10 to power x, so that we have u squared minus 5u plus 6 equals to 0, which is the same thing as u minus 3, u minus 2, u minus 3, right? Yes, this is equals to 0. Clearly, we have u is equals to 2, or u is equals to 3. Okay. Now, let's go back and see what is u. So u is equals to 10 to power x. It means that 2 is equals to 10 to power x. So what does that mean here? It means that x is just going to be log of what? Log of 2, right? Log of 2. Yes. Now, what is the second one? The second one is if you take u to be 3, it means that what is u? U is 3. No, remember u is 10 to power x. Let me put it this way. But we can take u to be 3. So it means 3 is 10 to power x. So it means x is just log of what? Log of 3. So let's call this one x1. So these are the 2 solutions we have, right? So we're going to say x1, one of the solution is log 2. And x2, which is the second solution, is log 3. So you need x1 plus x2, which is going to be log 2 plus log of what? 3. But this, we can change it to multiplication, which is just 2 times 3, right? So this is going to be log of what? Log of 6. So we're here. So this goes with A. Now, question number 8. Here, you see that this is log 2 and this is log 8. So it has to be under the same log. So we have log 2. This is x plus 5. We can write it to power 1 over 3 plus log of what? We can write this as 2 to base 3, then 3x minus 1, right? Now this k can go up, right? This k can go down here, so that this becomes log to base 2 of x to power 5, 3 plus, this will just be 1 over 3 log of 2, 3x minus 1. So what have we used? We have used the fact that if you have log of ak of x is 1 over k log of x, right? So let me write it here again. We know that log of ak of x is 1 over k log of a of x. Now this 1 over 3 also I can transfer it up so that we just have log to base 2 x plus 5, 1 over 3 plus log of 2, 3x minus 1 to power 1 over 3, right? And what we see here is that we have addition, right? We have addition. So something is missing. Look at here. This is equal to 2, so we should not forget. We're putting equal to 2 on the right-hand side. So here now, we can change this to multiplication so that it becomes log 2. So we have x plus 5 multiplied by what? So we have 1 over 3 times 3x minus 1 all to the power 3. All of this log to base 2 is equals to 2. Okay. Now, how do we solve this? So we can change this to what? We can just change it to exponential form. So I think I need more space here. So this is just going to be x plus what? 5 to power 1 over 3, 3x to power minus 1 to power 1 over 3, all is equals to what? 2 to power 2, which is 4, right? So let me come down here and complete it. This means that you have x plus 5 to power 1 over 3, 3x minus 1 to power 1 over 3, it's equals to 4. Now, to remove the cube, we can cube both sides, we can cube everything. If you cube both sides, this will become x plus 5, and this will be 3x minus 1, but this will become 4 cubed. So now what do? We have to solve this equation. So now we have to solve x plus 5 multiplied by 3x minus 1 equals to what? Equals to 64. So let's expand. This times this will give us 3x squared minus x plus 15x, right? Then minus 5. Then we can say minus 64 equals to 0 because 4 to the power 3 is minus 64. And this will lead us to a quadratic equation, right? So let's see, what will it become? This will be the quadratic equation, 3x squared minus what's, this will be plus 14x, and this is minus 69 is equals to 0. So we have this quadratic equation to solve, right? Now, what will this be? Solve this one minus 69, we can consider by factoring, and let's see what will work. So if we try to factor this one, we can factor this. This will be 3x plus what? 23. And now x minus 3. I think this will do the job. So here we get that what? X is going to be minus 23 over 3, or X is equals to what? Or X is equals to 3. But we know that what? We have to check, right? We have to check. See, minus 23 over 3, can it be a solution? Look at it here. Here, if you substitute 3, it's fine. If you substitute 3 here, it's good. You substitute 3 here, it's still going to be positive. But if you substitute minus 23 over 3 into this part here, you will have a problem because you have a negative number. So for that reason, we have to reject this one. So this is reject. So this is the only answer. X is equals to 3. Okay. Yeah. So now number 9. Let's see if I can have sufficient for that. So let's put this out. Okay. Now number 9 is similar to what we've done before, but it's just we have 2x minus 10 to the power 2 minus x plus 3 is equals to 0. Now we can multiply both sides by 2x. So we can multiply both sides by 2x, so that here becomes 2 to the power 2x minus 10 plus what? 3 times 2 to the power x is equals to 0. And now we can rewrite it as 2 to the power 2x plus 3 times 2x minus 10 equals to 0. So you can let u be 2 to the power x, so that here is u squared plus 3u minus 10 equals to 0. Now here you have two factors. So you have u, I think is u minus 2, right? And u plus 5 equals to 0. So u it's equals to 2, or u is equals to minus 5. But what is u? U is 2x, so you have 2x is equals to 2, or 2x is equals to minus 5. So clearly here, x is going to be 1. But here, x is going to be log of what? Minus 5, which is impossible. So you reject it. So our solution is just x is equals to 1. So the answer here is A. The answer here is also A, question number 8. Then finally, question number minus 64. And this will lead us to a quadratic equation, right? So let's see, what will it become? This will be the quadratic equation, 3x squared minus what's, this will be plus 14x, and this is minus 69 is equals to 0. So we have this quadratic equation to solve, right? Now, what will this be? Solve this one minus 69, we can consider by factoring, and let's see what will work. So if we try to factor this one, we can factor this. This will be 3x plus what? 23. And now x minus 3. I think this will do the job. So here we get that what? X is going to be minus 23 over 3, or x is equals to what? Or x is equals to 3. But we know that what? We have to check, right? We have to check. See, minus 23 over 3, can it be a solution? Look at it here. Here, if you substitute 3, it's fine. If you substitute 3 here, it's good. You substitute 3 here, it's still going to be positive. But if you substitute minus 23 over 3 into this part here, you will have a problem because you'll have a negative number. So for that reason, we have to reject this one. So this is reject. So this is the only answer, x is equals to 3. Okay. Yeah. So now number 9. Let's see if I can have sufficient for number. So let's put this out. Okay. Now number 9 is similar to what we've done before, but it's just we have 2x minus 10 to the power 2 minus x plus 3 is equals to 0. Now we can multiply both sides by 2x. So we can multiply both sides by 2x, so that here becomes 2 to the power 2x minus 10 plus what? 3 times 2 to the power x is equals to 0. And now we can rewrite it as 2 to the power 2x plus 3 times 2x minus 10 equals to 0. So you can let u be 2 to the power x, so that here is u squared plus 3u minus 10 equals to 0. Now here you have two factors. So you have u, I think is u minus 2, right? And u plus 5 equals to 0. So u it's equals to 2, or u is equals to minus 5. But what is u? U is 2x, so you have 2x is equals to 2, or 2x is equals to minus 5. So clearly here, x is going to be 1. But here, x is going to be log of what? Minus 5, which is impossible. So you reject it. So our solution is just x is equals to 1. So the answer here is A. The answer here is also A, question number 8. Then finally, question number 9. So for question number 9, we want to find x. Okay, so we just apply the what? We have to do like a change of base first here, because look at the bases here. This is base 4, and this is what? And this is base 25. So what is best? Which base can we go to? Can we go to, we can just take everything to base 10, maybe. It's fine, because, okay, let's write it. This one, we can make some, this is log to base 4 or 5. This one, we can write it as log of what? 5 squared, right? Then 2 power 2x equals to 1. Let's keep it simple here. So what will happen here? It means that these two can go down. So this will be, but this term, I can write it as log 5 over log 4. This is okay. I can write it like this. So it means I've gone to base what? To base 10, right? Now multiply this one here. I can have it as 1 over 2. Then it will just become log 5 of what? 2x. Everything equals to what? Equals to 1. So here, what can we do with these? What can we do with this half here? This half here, we can transfer it if we want, so that here becomes what? Here becomes power. Yes, so that here can become power. So I can write it as log base 5 log 4 times what? This is going to be log 5 of what? 2x all to power half. Everything is still equals to 1. Now, do we have any cancellation? No, really. Not really cancellation. Okay. So let's see how can we do this one. All right, so for this one, we have log to base 4 here, and here we have log to base 25. So we can just decide to change everything to log base 10. So to log base 10, this is going to be log base 10 of what's of 5, then log base 10 of 4. Remember, if you don't put the base, it means 10. While this one will just be log base 10 of what's 2x over log base 10 of what? 25, right? So this is just by change of base. Yes. So now we see that this we can write as log 5 over log of 4 times, this is nothing but log 2x. What is log 10 base 5? This is just log 5 to power 2, right? 5 to power 2. And this everything is equals to 1 on this side. So let's transfer to this other side. So this will still be log 5 over log 4. But this 5 over 2 can just become what? It can become, so it can become just half, right? So we can write times, this is log 2x, and here will just become 2. The 2 can go down. So we have 2 log 5. Everything is equals to 1. So here I can cancel easily. Log 5 can go with log 5. So here we just have 1 over 2. So this is just going to be log 2x over, remember there is a 2 here. Now for these 2, we can multiply here. So this is just 2 log what? 2 log 4. And this is just equals to 1. Now everything here I can write as half log what? 2x over log 4. It's equals to 1. But this is log to base 10, log to base 10. I can bring it to become 1. I can just write it as log to base what? 4 of what? 2x equals to 1. You see this one? And this one here, half here is just a constant. So if it's a constant, we can multiply both sides by 2. It's fine. So that we can have log to base 4 of 2x is just equals to what? It's equals to 2. And this means that what? 4 squared, 2x is going to be 4 squared, which is 16. So 2x is 16, and x is equals to what? 8. So this is the solution. But we can solve it another way, but I think this is fine. Just convert everything to base 10, then try to find your way out to get x. All right, so this is the end of this video. Thank you for watching. If you haven't subscribed yet, kindly do. And also share this video with your friends.